covering the last part of machine learning. So we were doing this topic, explore machine learning using Python, where in the first two classes, in the first two sessions, we have learned about what is machine learning, how can we do it, what is the basic architecture of machine learning, what are the steps involved right from the inception of data, how do you get data, how do you clean it, how do you reprocess it. So different steps we have seen, what it all mean to get rid of null values in the data, or how can we change data to some other value, replace it with some impute data if required, if there are lots of missing values. So let me share my screen. We'll just go through all that once again, and then we'll come to today's topic. I hope the screen is visible now.
Yes, Sonam, yeah.
Okay, thank you. So, see, we've talked about how a machine learns, different ways in which a machine learns. So we have learned about supervised, do you remember what types of machine learning techniques are there? Supervised and unsupervised machine learning techniques. Can you tell me which types of supervised learning techniques we have studied in this course? Which all algorithms you have studied in this course, which comes under the category of supervised machine learning? Regression, okay, and classification. Yeah, so these are two broad categories when we talk about supervised machine learning techniques. Regression is used for, when do you use classification, when do you use regression? In one line, when will you use a classification algorithm for machine learning, and when will you go for regression? Okay, classification is for discrete set of outputs, and binary output is also right. If you want answers in the form of 0, 1, true, false, yes, no, then you can go for classification. And for continuous numerical values, continuous, not discrete, continuous numerical values, if you have, then we can go for regression techniques. Yes, that mathematical approach. And regression, we have studied simple linear regression, multiple linear regression. I hope you remember that equation of line y is equal to m1 x1 plus m2 x2 plus m3 x3 and so on. So that is the regression procedure. After that, we talked about these categorical learning, classification. So classification, we have learned what is logistic regression. You know how it is different from the simple linear regression and multiple linear regression? Logistic regression. Now, why is this called? This is a classification approach. Logistic regression is a classification approach. Why is it called regression then? We are using that term regression here, but regression is used to predict continuous numerical values. We know that. So why the term logistic regression here? You remember? It fits data, then predict probability, and probability are numbers. Correct. That's the right answer. That is why basically, or you can say internally, this algorithm uses regression approach, which predicts numerical values in the form of probability, and those probabilities can be mapped to the classes. So it's generally used for binary classification. When we have a binary classifier, yes, no, true, false, then we usually go for logistic regression, the basic of which is regression. Okay, good that you remembered. Decision trees, where the model is prepared in the form of a rule set, in the form of a tree from top to bottom. So rules are prepared. Do we have a tree here like this? Hierarchy in the form of a hierarchy. Yes, attributes are arranged like this. K nearest neighbors. It works on the principle of, what's the principle of K nearest neighbor? Closest data points. Yes. K points which lie close to the current node will be studied to select the answer for the current node. Yes. So K closest points, K closest data points. That's why the name K nearest neighbors will be looked upon for getting the answer for the current node. So current node is supposed to behave like its K nearest neighbors. We believe this algorithm believes this. Support vector machine. What do we do in SVM support vector machine? We split the data. We find a hyperplane, the closest fit, the optimal hyperplane, right? And it splits the data into different classes. And then we have studied ensemble methods like bagging and boosting, which are actually hybrid models. Like they might be a mix of some decision trees, more than one decision trees taken together in horizontal hierarchy or in a vertical hierarchy. So they enhance the accuracy of these models. So these things we talked about for these algorithms we have studied, which falls under supervised type of machine learning. In the next session, we talked about what to do when we have some data which is not labeled. If you have unlabeled data, then we have to go for clustering. Clustering, what does clustering do? Clusters, it forms clusters. So it finds similarity between the elements and then groups the data into different clusters. So yeah, I think today we have to start from clustering. We didn't discuss this, no? Clustering was left for us and artificial neural network was left for us. Okay, so we'll start from this very topic. So unsupervised learning technique is used when you do not have a labeled data. When labels are not attached, imagine the data sets which you have seen so far and you do not have the labels, like price is not there in that house prediction data. What will happen if price is not there? You don't know what to predict, what meaning to get, what inference to get from the data. So in that case, what we do is we look around for the similarities between the nodes. Similarities might be based on different things, like maybe you can group elements based on their purchasing behavior, or maybe you can group people based on their localities, or maybe you want to group them based on their interests of what a certain group of people are trying to buy. So these recommender systems which you see in Amazon, Netflix, like it suggests your friends are watching this, maybe you are interested in watching this, or because you have watched these shows, so you might be interested in watching these particular shows. Have you observed that when you open these platforms, OTT platforms, it suggests you only those things related to what you have seen so far. So they are able to find that similarity between what you have seen so far, what you would be interested in, based on your search interest on that platform, or maybe your search interest on Google, or what you have seen in the past. So it collates all that information and uh, puts puts the content which is there on the site in different clusters. Like if you want to go for Marathi movies, so it forms a cluster of Marathi movies, like that. So clustering can be based on uh, different approaches. Here, to study clustering algorithm, what we are doing is we have taken a data set which contains some images. We'll be working on the images now. You can see this is a type of a image. Now, this is a grayscale image where you are seeing a number 2. So this is a handwritten data set. Like, what if you have written something on a paper and it has to be predicted by a machine? What has the person written? So different people might be having different ways of writing. See, somebody might write 2 like this, and if I say, then someone else might come and write 2 like this. There might be multiple ways of writing 2, isn't it? Someone might write like this, but all of them are 2. All of them are 2, and the machine learning algorithm should be able to identify that all these are 2. All these are 2. So let's say, suppose I have different n numbers of such images where I have characters, I have digits from 0 to 9. Now there are digits, this is a style of 0, this is 0, somebody writes 0 like this. So different images of 0, different images of 1, okay, different images of 2. So different ways in which numbers 0 to 9 are written. So this data set contains these type of images where these digits are written, handwritten in different ways, multiple ways. So let's say now what we will be doing here in this prediction here is we'll make our machine learn upon these images. So our machine should be able to learn that 2 can be written in this way or this style or this style. Let's say I have, for now, imagine I have only 3 images of 2 in my data set. Similarly, 0 can be written like this, or like this. So what your clustering algorithm will do, a clustering algorithm will identify the features and group this data into 10 sets. So it will form 10 clusters because I have 10 digits. I know this. I have 10 specific digits. So I would like to split my data, or I would like to form clusters of my images where each digit is grouped into one cluster. A 2 is written like this. So make a cluster of similar type of images. Make a cluster of similar type of images. All the ones together. There might be a possibility that somebody has written 8 and it looks like this. Okay, and it also falls in this cluster. Mistakes might be there. I'm not talking about that you'll get pure clusters here. There might be some kind of a mix in these images, but that's where we are talking about the predictions. They cannot be 100% accurate, isn't it? So, but I hope you have understood what we are going to do here. There are certain images of digits, handwritten digits. In this data set, you can download the data set, handwritten digits data set here. Now, I'll show you what this data set is. If you download this data set, uh, let's do it, then you will be able to understand what is happening here. I hope you have understood what we'll do. There are images. Clustering algorithm will group them into images. Then you will bring one new image. Okay, then you can bring one new image, such image, and check whether it is a digit 0 or 1 or 3 or 9. Okay, this is what we have to do here. I have downloaded this data set. Let me show you that first. Because we do not have images. This data set does not have images. It is a CSV file which contains the information about all the pixels. So that using that pixel information, images will be formed. Let me open that file and show you the contents. Here I've started sharing my screen. I hope you can see now. So this sheet, if not, it will come. Mhm. Okay, so this is the data set, what it contains. Pixel 0, 1, 2, 3. So you know that every image is formed of pixel. I hope everybody knows that your computer screen is also made up of pixels. So that image of 2 which you have seen, let's say it is this point number 1. Data point 1 is my image 2. Now, imagine you have one image. Let's say this was your image 2, and now divide this into pixels. So it stores the pixel information, this data set, like this. And let's draw this way also, some pixels. Okay. So this image will be divided into pixels. And let's say this is pixel 0, this is pixel 1, 2, 3, 4, 5, and this is 6, 6, 7, and so on. Okay, this is how you have to read. So pixel 0 is 0, pixel 1 is 0. So that means here you have 0, black. This is also black, 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 and so on. Okay, so intensity of this, whatever number is written here, talks about the intensity of the color which will be put here. Based on that, this 2 will be formed. Is this part okay? Is everyone able to understand how this is an image and how to read this data set? See, uh, if I talk about the image number one has lots of zeros. Only at few places, these places I could find some number. So wherever your pixel 150, 151, 152 lies, there will be a color change. Okay, this color intensity will be used for pixel number 150. Then at pixel number 151, some darker, uh, the pixel will be darkened. So these intensities specify what number is this. Let's see the endpoint. Okay, now you have to remember how many pixels are there. So it is 783. That means 784. 784. Okay, just remember this number, that my image is made up of total 784 pixels. Now, let us go back to the image. Okay, guys, you have seen how the data is there, how a particular image will be written. Now, see, you read this file. We know read CSV is used to read this file, MNIST data, which is a handwritten digits data set, which contains pixel intensities of digits captured as 28 cross 28 images. So this image is 28 pixel by 28 pixel, which will become 784. 828 cross 28 will become 784 pixels altogether. Now, you read this data set, you convert it to a 28 cross 28. See, pick up the first row. We are talking about only the first row, which I have shown you. Okay, the first data point, all the columns of the first data point reshape into 28 cross 28. Is this line okay? Have you understood what is happening here? Okay, so all these pixels, see, you have seen in the, let's say this is my row number 1, and you have seen here 0, 0. You can't see the screen? 28 cross 28, because this data set contains, see how many columns were there, 784 columns were there, na? 7, or you can say 784 pixels were there. So 784 pixels means 28 cross 28 image. So 28 pixels horizontally, 28 pixels vertically have been taken in this data set. That's how 784. So now refer to only row number 1, where you have 0, 0, 0, 0, 0, and so on. But at some places we saw it was 253. Some place it was, let's say, 200. So this pixel change will be there. Now these 784 columns are arranged into 28 cross 28 matrix. These 784 columns, we have to convert it to a 28 cross 28 matrix to get this image. So first 28 use it here, next 28 use here, third set of 28 use here. So finally what will become? Finally it will become a 28 cross 28 matrix. Nandini, you can see why you're not able to see, because I think she has left. Yeah, this is, let me tell you. So I hope everybody has understood why 28 cross 28, and because we have 784 pixels there. And to get this 28 by 28 matrix, we have written this second last step. Okay, now let me read it again. From this MNIST data, I hope you remember this iloc function is used to locate. Now this 0, comma 1, 0 to 1 means only zeroth row will be taken. iloc will ignore the last one. Okay. So only first row we are referring to. After this first row, put a comma. It means now we'll talk about columns, how many columns to take. Now there's a colon. This means this empty colon here, there's nothing on the left side of the colon. See, there's nothing here, there's nothing here on the right side of the colon. This means all the columns, take all the columns. So it is written like this, 0, colon 1. It means refer only to the first row, column, all columns. That means 784 columns. First row, 784 columns, and reshape it 28 by 28. All right. So now when you have reshaped it, so now our data is ready in the form of pixels. Imagine that matrix which is ready in this step. Now we just have to plot it. To plot it, we have inbuilt functions to do this. IM show and the syntax you can use to plot this grayscale images. So you have to tell this map function also. What has to be plotted? You have to say first IM, that is the matrix of numbers, the intensity matrix you have to give, and then the type grayscale images. So use this plt.scene.gray. It will plot this. This is just to show you. See, it has nothing to do with the process. This is for our understanding what we are trying to do. Okay. Finally, what you have to do is just we'll give these images to our algorithm, the clustering. We'll use k-means clustering model here to do this. So these images will feed to the model as we were doing earlier, and then model will learn, form clusters. Finally, we'll test our model on one new data point. Okay, so this is what we do. Here we are just understanding how our data looks like, how you can check what the number is if in between you want to study. So this clustering algorithm which we use here is k-means clustering algorithm. So again, k-means k data points. It will take the mean distance. Distance matrix will be the same Euclidean measure which we have seen in the supervised learning technique. You remember Euclidean distance? There are different ways of finding distances. We talked about it. Euclidean distance, Manhattan distance. I told you, I think Hamming distance also. So here Euclidean distance is used to find the closest points to find this. So now see how easy it is to build up the model. We just have to use this k-means. Make a model like earlier what we were writing, decision tree, or if the algorithm is naive Bayes, we just use that algorithm here, logistic regression, create an object of it, and tell how many clusters you're looking for. We want 10 clusters because we have digits 0 to 9. So make 10 clusters and prepare this model, fit this model on this MNIC data. See, we have not done anything, nothing. Just import this data. If you see this line. After this line, you can directly jump on and prepare or fit your model on this data directly. The intermediate steps were just to display the image. You have one attribute here which is called as labels. So this model is now fitted on your data. So clusters are formed at this stage. You know this. When we say fit the model, it means the job is done. The job which this algorithm has to do is done. Now you just have to check if you want to check what are the labels given to these models. So you can write model.labels. These labels have nothing to do with the digits because the digit was 0, so this label is 0. It's not like that. This mapping of 0 to 9 is just random numbers, just the labels given to uh, the all the clusters which are formed for internal processing. This 0 doesn't signify that. The digit would also be 0 here for cluster number 0. I mean to say, if this is, let's say there's a cluster. This is one cluster, this is third cluster. These are just indexes. The labels are just indexes of these clusters, 0, 1, 2. It has nothing to do with what this cluster contains. Maybe this 0 cluster contain all the nines. Maybe this one cluster contains 1, might be. Maybe this 2 cluster 2 contains 4, we don't know. These are just the labels, okay? See, from the broader perspective, what the algorithm does, we have seen. Now, let us understand what this k-means algorithm does here. So, if you see how different clusters are formed, then you can use this code to check how clusters are formed. Okay, internally. If you want to see the cluster formed by some group, so that label you have to specify here. Let's say cluster 1, we are talking about what is the digit which is contained in the cluster 1, which is labeled as 0. So we bring in all the values, MNIST data set, wherever it was labeled as 1. Have you observed when I showed you the data, that file, CSV file, were there any labels? Was that data set labeled? No. 784 columns were there, and each and every column contained either 0 or some pixel intensity value. It didn't have any labels because all were same, 0 or some intensity level was there. It didn't have any labels, but now when you have trained your model, when you have classified corresponding to each and every data point, a label is given for the first one. Remember the first row. So if let's say the first row was representing number 2, okay, so now a label is assigned to it that will be put to some cluster, and let's say that label for that cluster is 0. I think it is 0 because we are talking about 0 here, and 0 cluster has 2. So the first row which we are talking about, 0, 0, and then let's say at some place 200 was there, 250 was there, then again 0, 0. Okay, this row number 1 in our data set. Now a label is assigned to it internally, and what that label is? The number represents 2. Okay, number represents 2, but 2 lies in cluster 0. 2 lies in cluster 0. So the label of this first row will become 0. Is this okay? Now, see, we don't know how many clusters, how many images are there in cluster 1, but we know there are fixed number of clusters. There are fixed numbers of clusters. So let's pick some random, 5 random images from cluster 1. This cluster 1 now, we are referring to all the data points in my CSV file where this label is 0. Wherever this label is 0, that means pointing to label 0 points to digit 2. Label 0 points to digit 2. Okay, remember. Now, I cannot print all of them here. I'm not interested in that. The system will slow down. So what we've done here is pick just 5 random images from this cluster and plot them here to see how they look like, whether clustering has been done appropriately or not. So this cluster 1, if you go, and you can do it for all the images also if you want to see. Cluster 1 contains all the images which were labeled as 2 or the index number 0 by the algorithm, by k-means clustering. So this is just the step to pick five random values. Any 5 random images we can pick here, convert it again, reshape it, and using show here. That's it. This you have to Step by step, if you try to understand, you will come to know what is happening here. I've just told you what this code is doing. And the same thing again we can do for the next cluster. The cluster which is labeled as 1. See, cluster which is labeled as 1 contains all the zeros. Pick any 5 random images and 5 times you create the plot area and then reshape your row intensities, convert it to 28 cross 28 matrix and display it one by one we have to do. So that's taking a for loop, preparing plots for this and implementing it. So this k-means algorithm, what will it do? It will partition your data set, partition this data set into the number of clusters which we specify. So that's how it's able to work for the unlabeled data set. So your each data point which was there in the matrix in the CSV file, it will be assigned to any one of the cluster. Any one of the cluster based on, it will find the mean, or you can say the centroid data point of it. See what happens internally. Let me tell you. Okay, let's say I have a space here. This is page is too messy. I'll need a blank page. Wait. Okay, this is fine. Let's see, this is my plotting area. I want 10 clusters. So let's say I have picked up number of clusters can be decided. See, here we know because we have digits 0 to 9. So we know how many clusters we are looking for. Let's say you are doing some topic modeling. Some news articles have come. You want to group them into clusters. That's why we use them. See here also, I think it's written for topic modeling, clustering based on topics. Let's say there's a news agency and thousands of news articles come to the news agency. They have to put them into cluster. These many are sports article, these are finance, these are, entertainment ones. So buckets you have to decide on your own based on your need. So maybe they have 10 such pages in your newspapers are there. So these 10 pages have different headings, or you have only 5. So you want to group your data only in the 5. That depends entirely on your requirement, number of clusters. Okay, we were talking about how this works. So let's say for now 10, we'll go back to our example. So in this space, first of all, some randomly chosen centroid, or you can say the mean value of the cluster is identified for each of the data point. Let's say this is the center for my cluster number 0. Cluster 1 here, cluster 2 here, cluster 3 here, cluster 4 here, and so on, cluster 5 here. Okay. Now each and every data point is taken and see how close that data point fits to this location. If it is closer to this location, it will be present here in the vicinity of this. It will be marked here. If the second data point is closer to, let's say it is 1, it looks like 1, that will be marked here. So similarly, all your data points, I think somebody said 784. I didn't check how many rows are there. 784, if it is, all 784 data points will be marked on this graph here around this. Okay, like this, based on the distance, based on the Euclidean distance which we calculate. Then again, the mean is found of all these clusters. Mean of this cluster will be calculated and readjusted. Until we find a good cluster match. So maybe the mean of this will change based on the distance. This type of approach, this k-means clustering or the clustering approach works well when we do not have the labeled data and we have, see, some applications are given here, like one I told you for topic modeling or for sentiment analysis or for finding anomalies. If there's anything which goes out of the scope of this data, if somebody has like 0 to 9, except 0 to 9, if there's some image which is a letter A, let's say, this, suppose this data set contains a row which represents A, image of A. That will be an anomaly. That will be an anomaly for this data set because everything is lying between digits 0 to 9. Everything will lie in those clusters, but this A might not lie. Or it might be wrongly fitting into 9, the cluster of 9, but it will not closely resemble to it. So it helps you identify the anomalies in the data set as well. Okay, let's see. There are three questions for us. Music streaming applications automatically create playlists with similar songs. See, this is what we were talking about. Your OTT platforms, they group the data with similar content. Like these are Punjabi songs, these are Marathi movies. You know, these are this is for furniture section when you go to Amazon. So, what type of algorithm can be used to do this? We know logistic regression is for predicting numerical values. It works on label data set. Decision tree also works on label data. KNN stands for K nearest neighbors, which again works for supervised technique label data. K means algorithm will be used for this clustering activity, grouping. Next question, which of the following is incorrect with respect to K means clustering? Why three? See, one is not correct. It is used with okay, one is it is used with unlabeled data. This is right. It has to be used with unlabeled data. This is k-means clustering, not KNN. Names are confusing here. K near, it is not k nearest neighbors, it is k-means clustering. Use it on unlabeled data, we have seen why. It can be used to segregate news. This is also correct. It puts two dissimilar data points in one cluster. This is wrong. It puts similar data points in one cluster based on their distance. All right, so that was about the unsupervised learning approach. We'll move on to the next section where we learn about what are artificial neural networks. See, we have seen so many algorithms so far. These algorithms work well on text type of a data, on textual data, organized data, where your data might be in the form of some file, structured file like CSV file, JSON file, Excel file. So these algorithms work well there when the amount of data is limited. Then those algorithms give you very good accuracy, approximately 97, 98. You bring a data set, check their accuracy. It will be if the relationships between the attributes is good. I mean to say, if the data set is good and it has some dependencies which you can predict, then you get very good accuracies in the range 98 to 100% accuracy. Also, those algorithms might give you. But when the data becomes huge, humongous. Or when you talk about different type of media apart from the text data, like when we have let's say you give some reviews to the products. Now, let's say Amazon, so they want to identify what is the sentiment of the customers for this particular object. Do they like it, or people are disliking it? Which product has to be moved out from the shelf, which has to be kept, which has to be restocked? So if they want to make all these decisions, so the amount of data which they have to deal with is large, and this type of information might not be in a particular format, because I might give a comment in my, I might have my own style of writing, giving comment good bad. See, good bad excellent is okay. If I am using keywords, that is fine. But when we write big text in reviews, or and then sentiments have to be analyzed from that textual data which is in the form of big text, that is called unstructured type of a data. Or email, let's say some emails are coming and you want to know whether a particular application is liked, or whether there are bugs in these applications or not. So at that time, or let's say ticketing, you have some, let's say you have purchased some electronic item. Now you have written, if that product is not good, you want to complain, you're writing an email to the company. Lot of emails come to that organization, so those emails which come might have to be segregated, and everybody, each one might have a different way of writing that email. Now that those emails have to be studied, those thousands of emails have to be studied and kept into different bucket. Maybe this is maybe in red zone, it has to be given utmost priority. Then maybe next section, maybe these emails can wait, or the last section, maybe these emails, even we need not answer for these emails. So we have to group them into buckets. At that time, just remember, how will it be done? This is not structured data, your emails which we are talking about. So analyzing things becomes very difficult when we are talking about some different format of data, like analyzing images. This one image, or let's say I have 100 images here, or 700 images here in this data set. But what if I have to train my network on millions of images? Then it becomes very difficult to use these classical algorithms if you have huge amount of data. Now these were grayscale images. Imagine now if you have RGB images. If you have RGB images, then for one image you will have three such files. For all these images, you will have three such files, where one file will contain information about your the R intensity value, second file will contain information about G, third will contain about B. This becomes thrice. Amount of data becomes thrice when we go to the colored scape model. So when we talk about images, now think about videos. If we have to analyze something, put videos into different buckets, or study the videos, then how will it be done? So it is not possible for these algorithms to work upon different type of data apart from text. Or when textual data also becomes too large, then we have to go for some other type of learning techniques. So the learning techniques, our brain, human brain is capable of understanding so many things altogether. Understand what the person is talking about, understand the sentiment of the person by maybe the tone, judging the tone of a person, or the way in which it is told, or by focusing on the content part as well. So we understand how it is said. Like if I say, wow, this is very good. Or if I say, wow, this is very good. So there's a difference in tone. We understand. You might be able to understand where I was sarcastic, where I was actually saying good, isn't it? So, but when we write it, maybe our systems might not be able to capture it. These algorithms will not be able to capture all such details, whereas human brain can capture, and human brain can process a lot of information also. So these computer scientists have tried to understand how a human brain can understand so many things, how a human brain works, and they came up with a type of algorithm which works in a similar fashion, which is um, quite similar to the working of human brains. So here in these algorithms, these are also algorithms, neural networks are also algorithms, where we have intermediate nodes which are called as neurons. The data which is given to these algorithms passes through these nodes which are similar to the neuron network in our brain. So you can see a neuron in a brain looks like this. We have dendrites which capture information, then it goes to the cell body where we process. Every neuron does this. That neuron will process information in the cell body. Then from axon, it will be going to some other neuron where some other type of processing will happen. So information which, like if I'm talking, it is going through your ears to the brain and it is getting processed at multiple number of steps, not just one or two neurons. We know this. So this type of structure has been mapped to the algorithm. Like you can see here, in each of the neuron, what is happening, it takes input from different sources from the other neurons and applies some function to it. That function here in artificial neural network is called as activation function. These activation functions, the speciality of these functions is that they are not linear functions. Linear functions like what we have seen, if one increases, the other thing also increases. So fx is cannot be represented in the form of a linear equation, you can say. So they are non-linear functions. But some kind of functionality will be put on this. Some mapping will be done on these x1, x2, x3 values. And after transformation, after applying that function fx, some output will come. That output will go to the other set of neurons. And this process keeps on going in multiple layers, like how you can see in the diagram below. If you give certain input, it goes to the other layers. In the hidden layers, intermediate layers, all these processing happens based on the activation function. So the which activation functions we are using, that is also crucial to the working of the artificial neural network. It has generally three layers. We say input layer, which is the receiver, which receives the actual input, and a lot of hidden layers. This is only one layer you are seeing here, and there can be multiple. This might be a second layer. So layer number one, layer number two, and there are multiple layers. If there are lots of layers, millions of layers in between, then this artificial neural networks is also called as deep learning neural networks. You might have heard of it. Deep learning neural networks, which is used in transformers for developing generative AI applications. Okay, so these hidden layers in between, these are hidden layers. Now these layers are made up of maybe equal number of neurons or maybe unequal number of neurons. These are the neurons. These circles which you are seeing here, they are called as nodes, or you can say neurons, where processing happens. So every neuron, every node takes some input and gives output which goes to some other neuron for processing. Finally, you get some output. We'll talk more about it. Okay, so these are the basic components of artificial neural network, which you have seen. The nodes or the neurons where the activation function, or these are the actual computational unit where some computations will happen on the inputs. You have layers like how I've shown you, a two layer, three layers. So multiple layers can be there, which are group of neurons. Every layer is a group of neurons, which can be either consistent number of neurons in each layer, or it can be inconsistent also. These are called hidden layers. Activation functions are same. Activation function is a non-linear mathematical function which works on your input. It should tell you what type of functions are used. Okay, we have all the diagrams. We'll wait if okay, let's see an example here. These work on label data set as well as non-label data set. So we have different classes of neural networks which work on label data and different algorithms built using neural network approach, which works for unsupervised, that is unlabeled data as well. So it works for neural network approach, works for both the things. supervised as well as unsupervised, labeled as well as unlabeled data. Here, let's talk about the labeled data. Example is given for the labeled data. We want to predict, given the sugar levels of a person, age of a person, we want to predict whether the person is diabetic or not. So maybe based on prior understanding only we can do this. It is not about that we group these people into certain category. We want to ask this question whether people are diabetic or not. This that means we have a label data here. So you give that label data to this network. Neural network is just like a black box to which you give data and it gives you the predictions whether the person is diabetic or not diabetic. Now, internally, what is happening? Internally, that data which you are giving sugar level and age, it goes through all these layers. Okay, one layer after the another, and then finally it predicts whether the output layer tells you whether the person is diabetic or not diabetic. So input layer is just used to receive. So there no processing will happen in the input layer. It will take these inputs, sugar level and age, and pass it on to the other hidden layers. Layer number one, maybe you can say. Now in these layers you have neurons. Now what happens here in these neurons? Maybe let's say we have activation functions like we have sigmoid function, we have RELU function, and we have some other type of functions as well. So let's say what sigmoid function does is, I think it is the formula for sigmoid function is this 1 upon 1 plus e raised to the power minus z. So this function will map your, let's say this is x1, this is x2. Now some weights are assigned to these links as well. This is weight 1, this is weight 2, some weight here, weight 3. Okay, I'm just taking for example, let's say this z represents the same equation which we have studied in linear regression, multiple linear regression model. So this is, okay, not m, w, weight 1 times x1 plus weight 2 times x2 plus some error also in the end. Okay, this is represented by z, and the sigmoid function will convert, finally find this value and pass it on to the other layer. Something more lead some linear function I have used here, but then finally when you use this sigmoid function is fx, then it will give you a non-linear value. There will be no linear relationship between the input or the output which you have given based on these weights. So some weights are associated, some numbers we have to use in between, which are called as parameters of this network. These parameters in the first round, what happens? These parameters are randomly assigned, and then some output is perceived. Let's say when you assign some random weights and you have got non-diabetic. Okay. Now what will happen? You have given age of the person, let's say 65, and what was the second one? Age and sugar levels. Okay, let's say sugar level is greater than 100. And your model has predicted, this artificial neural network predicted that person is non-diabetic. Now, you know that when we are training our networks, then we have two phases, training phase and testing phase. So when you train your model and it has given you non-diabetic, you'll go back and check whether it is correct or not. During testing phase, you can see whether the person is actually the person was diabetic or non-diabetic. See, this is not inferencing. You have to see that we are still on training testing phase. We are talking about training testing phase, not the final inferencing phase. Model is not yet ready. During training phase, you give some inputs, input values, age and sugar level values to your model. It tries to predict something. You have the actual values, you can compare with the actual data, and then if it matches, then fine. There's no need to readjust these weights. If your data doesn't match, what will happen? You'll feed it back to the network. Okay, you will feed this information error rate back to the network, and the weights input will remain same. The weight W1, W2, and the error which was added to this. These parameters will be readjusted. These parameters will be readjusted. Again, it will find these values. Again, you can compare. So this is iterative process which keeps on going until it satisfies you with the accuracy. With some permissible error rates, obviously, it cannot be 100% accurate. Then when finally, when you are ready with this, there's no more change in the weights which you're expecting, then you finally go and deploy this model and bring in a new person. Let's say age is 85 and sugar level is greater than 100. Can you predict what is the status, diabetic or non-diabetic? There we do not have a chance to, test the model because we do not know. We are inferencing. At the time of inferencing, we do not know the actual values, the output values. Weights, we have seen what are weights. Weights and biases are parameters that are learned or that are adjusted iteratively to produce the desired results from the given inputs. Okay. Now, activation functions are of different types. When you get these error in the testing, if your values differ or if your error rate is above some threshold, then we use some mathematical techniques like stochastic gradient descent or AIML to readjust these parameters and to adjust or to uh, assign the optimal set of weights. So this also we can specify, like how we were choosing the model. Here you have liberty to choose the activation function when you give your, when you are picking up any artificial neural network, then it gives you certain hyperparameters like choosing control for what type of correction measure you are looking for, weight adjustment, which algorithm for weight adjustment you are looking for, or which activation function out of a given set of activation functions. It gives you a choice to choose which activation function you want to go for. So somewhere you might see this term Adam optimizer is used. Has it come somewhere? I think I've seen it somewhere. Was it used, Adam, somewhere in this course? No? Oh, no, I think in some other course I might have seen. Okay, we have it. That's good. Activation function. We'll go to page 1 first of all. Now, these are some of the activation functions explained here. You can see these are transfer functions, which are non-linear. So they convert the input values to the output values. They are good for finding non-linear relationship between the data. So see what happens when you use a linear function to map like y is equal to m1 x1 plus m2 x2 is a linear function. So if you start using a linear function, then your neural network will start behaving as a regression algorithm only, linear regression algorithm only. So these are some of the popularly used activation functions in neural networks, like I told you, sigmoid, linear activation function. If linear activation is used, it will be regression only. Softmax, softplus, ReLU, soft ReLU. These are the functions. Now, what will happen here? Maybe the fx is different. Fx is different in this case. Like earlier, it was 1 upon 1 plus e raised to the power minus d. That will change. That formula will change for all these functions for finding. So here you can see linear activation function will give you a linear line. So it will map all the x to y's in a linear fashion. Binary step gives you either 0 or 1 in the form of binary step values. It will change the values to this. Okay, ReLU graph comes like this. Softmax you can see, soft plus and leaky ReLU. These are different set of functions. Now there's one more thing which is these functions does is, let's say, okay, if I sugar level will be, what will be the sugar level? Maybe 0 to some range, let's take 500. And age will be 0 to 100, okay? Approximately same. Let's take something else like in, you remember that car data set was there, in that we talked about MPG. Let's say we want to predict miles per gallon. MPG of the car in the city, and we based on two parameters like kilometers driven and age of the car. Let's say age of the car. So age of the car domain would be, the range of the values for age of the car might be 0 to 20 years old. But kilometers driven will be 0 to 10,000, 50,000, maybe lakhs. Okay, let's say this is my range. So there's a difference between 0 to 20 and 0 to 1 lakh. Now, if I start doing W1 internally, for now, just imagine I'm doing taking a linear function. If I do W1 of X1, that is kilometers driven, and I take W2 of years, then do you think there will be any difference if I keep on changing this? My output will only be governed by my kilometer values, isn't it? Guys, I hope you can relate to this. We have already talked about this normalization, scalar, standard scalar, min max normalization we have studied. There also we talked about the same thing. Remember, so my output here will be governed by only kilometer and not years. Years will not make any change to my output. So these activation functions, they bring your data to a certain limit, like normalization. What was normalization doing? Normalization was bringing, min max was bringing your data somewhere between, maybe in a range, -1 or 1, 0 to 1, in some specific range, isn't it? Here also same thing is happening. These uh, these functions, these activation functions which we are using, they map your data to a proper scale, to some value, to some within a range. Your values come within a range. So normalization also is happening internally in these functions. Okay, so Deepni is asking, how do we know which algorithm has to be used here, which will fit our data set here? See, here we have to just keep on changing. There's no fixed rule again, which algorithm you have to use for which cases. These are available. You have to, based on the performance or based on the accuracy, you have to keep checking the accuracy. We know now how to check for the accuracy during the testing phase. So based on the accuracy, we can keep on changing these algorithms, these activation functions. The now you can see here internally what they are doing. Okay, sigmoid I already told you is 1 upon 1 plus e raised to the power minus x, where x is again calculated by some fashion. Linear will just do a into x, like y is equal to mx is your linear. So a straight line comes when you take a any choose any of the linear function. Your binary step, what is it doing? If the value is greater than equal to 0, make it 1 or 0. Sigmoid function, tan h function finds tan h. So these are, see, actually the range will vary here. The approach of these will give you different ranges. It's not that all of them will lie in 0 to 1 or -1 to 1. Yes, that's what you have to do. We have to see which activation function is supported by the algorithm which you have chosen and keep on trying. Activation is for non-linear, yes. But when here you are choosing a linear activation function in neural networks, if you choose a linear, they can behave as regression algorithm. They'll start behaving as your linear regression algorithm. Yeah, yes, so deeply. See, if after number of iterations, there are a lot of things. See, hyper controls, all the hyper controls like we have seen, number of clusters maybe you try to change, or maybe the error algorithms which you have chosen that can be changed, or the type of neural network algorithm which you are using itself can be changed. So all these things you have to keep changing and see. It's not that you picked one random XYZ algorithm and you started working on it. If that accuracy satisfies you, it's okay. Otherwise, we have to change all these things and keep checking. Okay, this talks about the same thing which I told you. Input layer, hidden layer, some bias is also some constant value is, maybe added to the hidden layer at each hidden layer. These biases can also readjust themselves. And this is forward propagation. So when you give your input values, these weights are assigned, and activation function calculates something, give it to the other layer. Finally, output layer tells you they predict something. Then in the back propagation layer, you go back, propagate the errors. Okay, so these errors are propagated and feed it back to the system so that these weights can be readjusted. Same thing which we talked about earlier. Now building will be super easy here. Okay, so this is just checking. We'll talk about this later. We'll start from here only. Okay, the same data set, our handwritten digits data set. Uh, Now this time we have two files, two different files. If you download this, one will be training file, the other is the test file. So data is split and kept into two files just like that. But when you download this data, you will have corresponding labels as well. We are doing classification. We are trying to classify this time using ANN network, and this data set when you download will have labels as well. You want me to show you? I'll download this. Wait. Weights will be some first stage, weights will be some randomly assigned values. After that, these weights will be readjusted based on the algorithm which you have chosen. Like if you choose Adam, there will be a certain technique in which it will ask weights to get readjusted based on the error component which you have got.
Sonam, your screen sharing is stopped.
Yes, yes, Prithvi, I'm downloading. I stopped it because I have to reshare it. It's actually unzipping. Just give me 1 minute.
Okay.
Yeah, it opened now. I'll share. Can you see the difference? Guys, I hope the screen is visible and you can make the difference now in this data set. This is a label data set. So already we have labels assigned to it. This first row label is 1. Label 1 means, does that mean digit 1? No. Label 1 might not mean digit 1, okay? We don't know. Label assigned here is 1. See here, in that case, when it is done by the clustering algorithm, there it was not meaning number 1, but here we don't know. It might be number 1 also because these are handwritten labels, so we don't know. It should be ideally 1 actually. And similarly, we have two files. This is for training purpose, and the second file you will see here is for testing, same type of a file. Okay, let us go back to the course and check the procedure now, what has to be done. Again, started sharing the screen. Okay, quickly we'll see what is happening here. Uh, you know now first column contains labels. So apart from, if I have to ignore first column and then take remaining columns, then only I'll get that 28 cross 28 image. So except this one colon here tells you start from 1. Skip zeroth column because zeroth column contains label. Make an array of this and then keep it in train data digit 1. Now from the testing data, pick up the first one, preparing the test data. Your test data will not have labels, or will it have labels? Testing. Yes, test data should have labels for checking accuracy. Let me see whether it has or not. With this test data doesn't have labels. That means we'll be using it for predicting. For prediction purpose, we'll be using it, not for checking the test accuracy. It doesn't contains label. That's why the test data can be taken right from the zeroth column here. So plotting for training data. Training data first digit you can see looks like this, the first one, and the first digit in the test data is looking like this. Same IM show grayscale function we have used. In your training data set, now you know what is X. In your training data, your column 0, column number 0 becomes your Y, and remaining columns becomes your X. Is this part okay? Training data set. when we are trying to train our data. So this 28 cross 28 pixel intensity information will be stored from column number 1 till 784th column. And my column 0 contains my y values, that is labels 1, 2, 4 we have seen. Let's build the artificial neural network. So the network which we are using here, ANN artificial neural network algorithm which we are using here is MLP classifier. MLP classifier is multi-layer perceptron classifier. Perceptron is a very basic single layer neural network. It's called a perceptron. And here we are using, this is the name of algorithm, artificial neural network algorithm, which is used for classification, MLP classifier. If you want to do it for regression, we have other class of algorithm, maybe MLP regress, its name will be regressor. If you want to go for clustering, so the name of the algorithm will change. So we have different algorithms under artificial neural network for performing each of these tasks. Here we are trying to classify based on our pixel intensity. We are trying to train the model on the labeled data set. On the training labeled data set, we'll train our model and then we'll try to predict the labels of the test data. So you use this MLP classifier as an sklearn library neural underscore this. From this package, we can import MLP classifier, generate a model, and specify the hidden layer sizes as well. See, randomly here we have picked, usually you will see 50 here, it starts from 50. Number of hidden layers you want to keep in these models. Fit this model on the training data. Now, once your model is fitted, then we can go for prediction. So from the test data set where we didn't have the labels, pick up the first row. First row, when you give to this model, it predicts the number. So the model has learned that this is the label for this first row is 2. And here in the previous page, we have already checked that first digit in our test data set was 2. Layer sizes, how many layers will be there, or how many nodes per layers will be there, there's no fixed rule for it. I hope you have understood what is happening here. We have taken a label data set, we have trained MLP classifier on that data set so that it learns classification rules. And then on the test data, we have tried to predict the label of the first row only, we have seen. Predicting results only for the first row. And how do we know it is correct? For that, we have plotted it here and we have seen whether it is matching or not. Just for understanding the correctness of the model. Otherwise, we have no way to check the accuracy of this. If this starts giving us some, let's say it might have given you 0. So there's no way for us to check whether it was 0 or not otherwise. If you do not plot it and say, because actual labels were not given. This is not the right approach. What should have been done here is maybe you could have picked one of the a data point from the existing training data, then you go for prediction, then again you check whether they are doing it correct or not. But their accuracy is far better than the conventional algorithms which you use. You can check the accuracy of the model by printing this classification report, which gives you the precision row-wise, column-wise. For every data point it gives you, for all the clusters, it tells you that. See here, have we talked about this precision recall F1 score? Was it there for you? Confusion matrix. Have we talked about that? Have we seen it in some course? Confusion matrix. Okay, confusion matrix we have talked about, na? And how it gives you accuracy, FPTP, false positive, false negative, true positive. Okay, right, right. Okay, in confusion matrix we have these terms, na? So let's say if I have two things, it tells you actually and the prediction values. So actually, if it is a yes or no, how many it was predicted yes and correctly predicted no. So this confusion matrix tells you, let's say I have um, 200 data points which were yes and correctly predicted yes. I had 200, I have 100 no's which were predicted yes. It tells you this. There were, let's say, randomly I'm taking 150 values which were actually yes but predicted no. There were 80 such data points where the actually it was no and they were predicted also no. So the how will you find the accuracy of this? The correct predictions are 200 and 800. These are the correctly predicted values. So what you can do is accuracy can be 200 plus 80 divided by sum of all this 200 plus 150 plus 100 plus 80. This becomes your accuracy. This is one matrix which helps you check what is the accuracy of this model. Now, out of this confusion matrix, some other matrix like precision recall F1 score also can be calculated, which are like precision gives you this. If I take a sum of this row wise and column wise, this is 350 here. I have 180 here. And here I have 300. Here we have 230. So what is this 300 telling us? 300 tells us actually the data points which were predicted, yes. And what is this 350 tells you? This 350 tells you how many data points were actually yes. Actually yes. So if I do 200 by 300, 350 here, this 200 by 350, what it gives me another matrix. It is not accuracy, but what am I checking here? 200 by 350. Actually, 350 data points were yes, but only 200 were predicted yes. So it tells me the accuracy with which your model, yeah, precision, the precision or accuracy with which your model can correctly predict y values. Isn't it? That's it. That is precision. So for each and every, oh God, y or n. Similarly, you can calculate for n as well if you do. So there we did 200 by 350. Okay. Now, if I do 200 by 300, it will give me some other statistic. What does it tell you? 200 by 300. In our matrix, this 2 by 2 matrix, 300 was here. The total of yes or no. This is yes or no. This is actual prediction. This is actual values, and these are predicted values. 300 data points were predicted yes, but whereas only 200 were actually yes. That gives you another type of matrix. So these matrix, precision, recall, F1 score, they are, and F1 score is harmonic mean. Maybe you'll have it in next course, I think. It should have been there somewhere. But all these matrix are dependent on this confusion matrix. There are other ways of checking how accurate your model is. So all of them can be put together in this classification report if you generate on the training data set. So here, how do we read it? See, support is 4132. It shows us that there were 4132 instances where the label was 0. Actually, there were 4132 instances. And precision, that means how accurately we can predict, your model can predict 0 is 0.99. Recall is also 0.99. F1 score also is 0.99. It tells you bitwise for all these unique values, for all these unique classes 0 to 9, it tells you the accuracy of the model with which it can predict 9 or 0. See, this helps you understand that if the data is equally distributed among the classes, then accuracy also is good enough. But if the data is skewed, let's say I have more number of data for 0, less for 9, then it's better to understand for each and every class which class is predicted well by this particular model. Maybe it is not able to predict well for number 9, digit 9. Support tells you the actual data points. This 4401 is telling you there are 4401 rows in your data set where the label is 7. How many times 7 comes in your data set? 7 comes as a label in your data set. Okay, actual total accuracy is coming to be 0.99 and total support is 42,000. So totally we have 42,000 rows in the data set, out of which the total accuracy of this model is coming to be 99%. You can see this is actually too high for any of the classification algorithm. If you do, they might not be able to give you this accuracy. So that's why neural networks are preferred these days. Okay, we have two questions. This is easy one. Which of the following are responsible for non-linear output of an artificial neural network? What makes it non-linear? Function. Activation function will make it non-linear, not the weights and biases. They are just numbers. The function will change this aspect. During the learning phase of ANN, the weights and biases are never altered. This is wrong. Altered during forward propagation? No. Altered during backward propagation? This is correct. When you back propagate the errors, then only they'll learn and they will be readjusted. Okay, I think we have completed this course, and this is all about what you have seen in this course. There's no need to tell you what you have. If you want to learn more, you can check these references. This is the capstone project which I was talking about. You have to download the data set here. This data set has roughly 15,000 records with some columns like satisfaction level, last evaluation number of the project, average monthly hours. Okay, some columns are there. Yeah. So you have to download this data set to understand. I think it should be a labeled data set where this left column will tell you about whether the person has exited the organization or not. So maybe based on the other parameters like satisfaction level of the person working in the company, for how many time for how much, now how many number of years the person has worked, average monthly hours of the person. So based on all these things, the organization wants to study the reason maybe based on which a person is likely to exit the organization. So you can implement, see, they are not asking you to do anything specific here, do this, do that, but just they're asking you to generate a machine learning model to study the exit of employees, whether they will exit the organization or not. So right from the very starting, I think this should be a this classification algorithm. I think it will call for you have to check what is this left. Is it yes or no? Then based on that, you can take a call. If any of the attribute is categorical, then you can convert it to using hot dummies, you can encode it. Here, I think satisfaction level and a department, these are the categorical columns. So you can convert it using hot encoding. So that all that pre-processing also you have to do. If you do not pre-process, directly give this data to the machine learning algorithm, then also it might be able to give you some answer, but that might not be good enough. The prediction might not be good enough. So it's better always to clean your data and then go ahead. Okay, and then finally you have this assessment which has only 12 questions. This you can complete once you go through the course. Then you can think of completing this assessment as well. Okay, now let me know. We have finished early today. If you have any doubt, please let me know now. Or if you want to go, you can go ahead and complete the assessment as well.